In this video, we are going to be going over the 3 different rules when you are filling your orbital diagrams. Starting with the Aufbau principle, which states that lower energy orbitals fill before higher energy orbitals. Now we can remember the order of the energy levels of these subshells by using the diagram on the right here of the order of the subshells. You can go to my previous video to see how we wrote this out, and is a very easy way to memorize. So you just draw arrows down like this. You can see the 1s orbital is first, and then the 2s orbital comes next, and then on the third arrow the 2p orbital comes third, and the 3s orbital is fourth. And we can keep doing this if we needed to, but in this case we're just going to use the first 3 subshells. So if we were to fill this orbital diagram here correctly using Aufbau's principle, it would look something like this. And now if we were to violate Aufbau, it would look something like this. Now you can see how we completely skipped over the 2s subshell there, which is a violation of Aufbau because it is a lower energy orbital than the 2p subshell. So these electrons that I put in 2p, at least 2 of them, would need to be back in the 2s subshell. Now moving on to the Pauli Exclusion Principle, which states that no 2 electrons can be identified by the same set of quantum numbers, so they must have different spins, in other words. So if you remember from the previous video, N, L, M sub L, and M sub S are our quantum numbers. So let's fill the orbital diagram correctly again, keeping in mind we don't want to violate any of our principles here. And now if we were to violate Pauli's exclusion principle, we would see something like this, where there is 2 electrons that are going in the same direction. Now if we were to write out the 4 quantum numbers for both of those electrons, which they cannot be the same according to the Pauli exclusion principle, N is 2 for both, L is 0 because it is the S subshell, ML would be 0, and the spin would be positive 1/2, in which case one would need to be negative 1/2 to not violate Pauli's exclusion principle, so therefore this would be incorrect. Lastly, we have Hund's rule, which states that 1 electron goes into each orbital until all of them are half full before pairing up. So again, this may seem repetitive, but it's good practice to fill these correctly. So now let's violate Hund's rule. So we're filling it normally, but then we pair this electron before it goes in there. This is a violation of Hund's rule because that electron needs to have the M sub L number of 1 before it can start pairing with the other electrons to form those electron pairs, and then we can advance to the 3s orbital, but in this case we cannot get that far because we don't have enough electrons. So if this was written out correctly, we would have 3 separate electrons, and we wouldn't have that paired. I hope this video was helpful. If you thought it was helpful, consider liking the video or subscribing to the channel. Thank you so much.